I am working on a King's Controls cruise control unit from a 1994 Monaco motorhome with the diesel 8.3. This cruise control has stopped working. I've decided to remove it, see if I can find any faults, and if I can to repair them and then reinstall it. Now the model number on this is 9-002500, and there's the serial number on the model. Obviously I've removed this already, and let me talk a little bit about how these work. These have a servo unit mounted on the bottom, goes through the chassis of the box. The servo unit attaches to a cable. Cable comes out the size of the box and attaches to the throttle, the engine, the motor of the motorhome. So the whole purpose of this device is to drive or hold the throttle position to maintain a particular speed. Has a number of inputs, has a power input, and there's a ground. The power in this case is actually this red wire, at this level anyways, and the black wire, it shows as green there, but if we extend it over here you can see it's black. But we've got red, and those are coming in from this wire that leads into the box, and that wire that leads into the box goes to these connectors. We have two connectors on this unit. This is the main power one actually, and the wire is coming out of the harness. The red does correspond to this one on that terminal. And you can see that looks like it's been heat damaged. And that green is that ground wire. And then I will get back to you. Okay, I verified the continuity on those two wires, the red hot wire and the black ground wire, to those positions on the harness. And this is important because I'm probably going to end up injecting some voltage in this ultimately. And that would ordinarily be a 12 volt input. The way these systems are designed, they have a brake pedal override, and that shows up in here through the existing brake switch. If you depress the brake switch, it turns off the cruise control via this circuit here, this green wire. And aside from that, this particular design, the 2600, has the foot throttle connector, which I do not have. That's down here. And what else does it have? A connector for the throttle position sensor. And I seem to be missing this in the 2500 system as well. So in my system, it's only the two connector, and considerably less complex. Well, where do we go from here? Visual inspection is what I started with. And right away, you've got some heat damage on those connectors. If we start looking at the circuit board itself, I'll focus that in a bit. We've got some LEDs on it. These are used for diagnostics. When I apply power, if it's functioning, certain of these lights are supposed to light up, and that actually is in the diagnostic flow chart, and I'll get back to that. But if we start, the first thing you usually expect is that you've got blown capacitors. When I started looking at this, I didn't see any obvious heat damage in the circuitry itself. On closer inspection, when I was looking this over, I did find, look at R29. R29 is just the ends of the resistor. The resistor itself is completely missing. It's burnt out. Well, this is problematic because I don't know what the resistor 29 was, what its resistance was. What I'm going to do is I'm going to pull the board, I'm going to try and study the circuitry and see where that resistor 29 falls into the circuit. If it goes to a chip, I'll be able to bring up the chip specifications. From the chip specifications, I could probably determine what the resistance of that should be. So that's the approach I'm going to take to try and fix this. So at this point, the board is still in the enclosure, the box. I'm also going to test every transistor I can find that's on the board, and there are a couple of them. And again, I'll test them in place, and I'm going to get a much better idea of the integrity of the circuitry overall when I remove this and flip it. So I'm going to stop here. Okay, I've got the board out. Let's inspect this together. Now you can get a better look at that resistor 29. And thankfully these connectors just pull off. And you can see the burning on that power input. Now that I've got it out, looking at this large diode here, it's looking a little bit cooked on the end. I'm probably going to pull that diode and test it. This resistor here too looks like it suffered some heat. And let's flip the board now. So here's where the main connector came in with the hot wire and the ground. And yeah, it's looking a little bit burnt on the backside. Let's see if we've got some destroyed traces there. Yeah, it's not cleaning up very well. I'll try a toothbrush on that. You see we got some corrosion. Oh, let's see, where is it here? Oh, on this soldered point right there, and that corresponds to, it is 7805 CT on a very large heat sink. This is pulling right loose. I can pull that out. Just going to put that back. I'll just set that down for now. I'm going to take a soldering iron and clean up these two positions. Now I'm going to have to try and figure out where that goes to. It looks to me as though the circuit is here. Yeah, that's a trace. It's peeling up. I'm using my knife to expose that. Oops, don't want to break that off. And it seems to follow. See where that conformal coating is peeled off? I think this peeling on the conformal coating has been because of heating. If we trace that, like trace this circuit here, it comes down to this connector, which looks like it's poorly soldered now. This may have come loose partially through heat. And what does that connect to? Just going to put my finger on that and flip it over. And it's the other end of that transistor on the heatsink. For now, I'm going to clean this up with my knife. Now it appears to go in this direction too. I'm wondering if it's contiguous with this circuit here. Maybe I'll turn this to a tone so you can hear it. I don't know if you'll be able to hear it with this mic. Probably not. So we'll connect one end here, one end here, and I do have a circuit. I'm getting a beep and 000 on my, I've got it in diode mode, so 000 for the voltage drop. So those two circuits are contiguous. So let's check it here. Yeah, I'm getting it here as well. If we go from here to here, again I get the beep. It's part of the same circuit. So what we're going to need to do is replace this electrode, or this connector electrode here, solder it in, resolder this ground one, and this ground plane seems to be this circuit here. This is the printed circuitry, and that ground appears to be shared from here to here. Yeah, I'm not getting continuity, so I definitely have to resolder that connector as well. I think it overheated to the point where it's just not connecting to that plane. Now to get on with determining what that resistor was. Where was it again? Okay, there it is. Right. R29. Okay, well, where did R29 go? Okay, it's time to bring you up to speed. I've been messing around with this for quite a while. Ended up replacing that resistor, and I replaced it with a 100 ohm resistor. That's this one here. Well, why did I do that? Well, I ended up tracing it to the number 8 pin of this chip. And when I looked up what that number 8 pin is, it's actually invert power, which is negative 12 volt, I guess, in this system. But that really didn't help me all that much. What I ended up doing instead is I looked, there's some duplicates of this chip in here. Here's another one, 339N. And here's another one down here, LM339N. What I did is I traced pin 8, which is this one here, because the numbering goes from 1, 2, 3, 4, 5, 6, 7 to 8. I traced pin 8 to other resistors to see which resistors typically go to pin 8 on these chips, and those were the brown, black, brown, such as this one up here, brown, black, brown, and it traced to pin 8 of one of those chips. So based on that, I assumed that this one was, oh, and that's 100 ohm. I assumed the one that was missing was also 100 ohm since it linked to pin 8. Whether this is correct or not, I don't know. But what I can do and what I did do is I hooked up power to these terminals. And the positive was the red wire that came in. And if you remember from earlier in the video, that red wire connected to the second terminal from the end. The black wire hooked up to the terminal closest to the end. Now, according to the diagnostic chart, take cover off the box. With key on, are there red lights blinking inside of the actuator on the circuit board? If so, locate the large LED, red LED at the edge of the circuit board with cruise switch in the off position. Is it flashing 4 quick blinks every 4 seconds? Well, this one is, in fact, flashing about once a second. There is no break between the flashes, so I don't know if that's 4 or not, but again, that's not the right. It was so badly shorted that the circuit for terminal 2 wasn't actually completing. Terminal 2 should connect to the end of a diode. One terminal of the diode is here, the other terminal of the diode is there. So that circuit occurs actually on top of the board. This is a double-sided board. And that is terminal 2, this one here, connects to this circuit, which goes over here, goes underneath the diode, then connects to that end of the diode, which is the positive end of a diode. So I ran a jumper wire on the other side from that terminal to this end of the diode, and then I got a good circuit, good continuity. What else do I have to show you? You can see there's some sort of a creamy solution on the on here. This is actually epoxy that's drying. The heat from this burning out melted the plastic, so this wasn't tight in the plastic holder. There's too much play in it, so I've put epoxy on it to hold it. Once that sets, that'll be good and solid. Anything else I wanted to say that I did on here? Those caps actually look pretty good, so I'm just going to leave all the capacitors. And I'm going to reinstall this once the epoxy is set, and we'll see whether or not I've got cruise control. That was it. I did say I was going to replace a bunch of caps, and I did not. Those caps actually look pretty good, so I'm just going to leave all the capacitors. And I cleaned up the corrosion over here a little bit. And I'm going to reinstall this, which will probably be sometime tomorrow. And we'll see whether or not I've got cruise control. Thanks for watching.